Hey guys, hey, hope you're doing great. Here we are, chapter 3. Welcome to it. So we're going to be doing 3-1 today. So we're on pages 160, 161 in our workbook. Here we go. So we're learning about these weird things we call inputs, outputs, relations, functions, all kinds of new words. Take good notes here. Get that out of your way.
When is a relation a function? Think about this question during the lesson. Jonah is shipping 5 boxes for his uncle. Each box is the same size but a different weight. The cost to ship each box is shown. Should Jonah expect that the cost to ship a 15-pound box will be a unique cost?
Maybe. Well, yeah, I don't know.
You can begin by stacking the boxes according to their weight. Put the heaviest box on the bottom. Is there a relationship between the weight of the box and the cost to ship the box?
What do you guys think? So is there a relationship here between the weight and the amount that we pay to ship it?
I see one.
I do too, guys. As the weight increases, what happens to the amount that we spend to ship it? Goes up as well.
The heavier the package, the greater the cost.
There you go. That makes
However,
sense.
the costs do not increase at a constant rate.
Oh.
Stinkers.
Now organize the data using ordered pairs. Input, weight, and output, cost.
X value, Y value.
The top box weighs 8 pounds and costs $8.56
Should have 5
to
ordered
ship.
pairs here, one for each
The
box.
ordered pair is 8 and 56 hundredths. The next box weighs 9 pounds and costs $8.72. 10 pounds costs $9.01. 12 pounds costs $9.55. And 14 pounds costs $10.03.
Wow.
Any set of ordered pairs, like the 5 we have here, is called a relation.
There you go. So there's one of our new words, relation. It is just a group of ordered pairs. In this case, we had 5 ordered pairs. They make up what is called this new word, a relation. Okay? Remember, ordered pair is just an X value with a Y value. We will also call our X values inputs and our Y values outputs.
Let's use an arrow diagram to match each input
These
value
are new.
to
We've
its
never done
output
these
value.
before.
Let's do that.
8 pounds on one side, $8.56 on the other.
Input.
And we can repeat
Output.
this for the other 4 ordered pairs. Which group represents the outputs?
Remember, the outputs are
Select
the
your
Y
answer.
values. Outputs are the Y values. Look at all those ordered pairs over here. Where are those Y numbers? 856, 872, 901, 955, 1003. Right? Yeah, they're all right here.
A relation is a function when each input is assigned exactly one output.
Okay, so
Is the relation shown a function?
well, I don't know, but we're gonna figure it out. So guys, we've maybe talked about functions before. Here is when we think of functions now, each input is assigned exactly one output.
How many?
Exactly one.
Exactly.
Not at least one, Math Excel, hint, wink, wink. Not more than one, not less than one, but exactly one output. So does each input have one output, right? Well, yeah, each one of these inputs, those were weights, have exactly one output. That is cost, okay? And this is one of the things we are going to be trying to figure out all over chapter 3 is this a function? Okay? So is this arrow diagram a function? In this case, yes it is.
That's awesome.
It's good stuff.
The diagram shows that for each input, there's exactly one output.
Exactly.
The relation is a function.
So Jonah can expect that the cost to ship a 15-pound box will be a unique cost. So what do you expect to be true about the cost for Jonah to ship a 15-pound box?
So if we had like a 15 down here, what kind of number do you think that would go to? That's somebody said it. Did you hear it? Somebody
something more.
Somebody said more than 1003. Yeah, absolutely.
Gotta be.
Absolutely.
More weight, the more price.
Okay? All right, guys. Hey, here's our try it for example number 1. So once again, we will be making arrow diagrams. So they've started to make one here, and they're using all of these ordered pairs here to make that one. So I think they left out a couple of inputs.
Uh-oh.
Remember, these are inputs. On the right, we have outputs. All right, so we have to look through my inputs in these ordered pairs and figure out which two numbers we're missing. Remember, inputs are x values. So I'm just going to read off my x values. 4, 5, 8, 2, 9. 5, 2, 9. So guys, we're missing 4 and we're missing 8. Okay? Now, my arrow diagram is not done. I have to do what they've done here, which is draw an arrow from your input to whatever output it goes to. Okay, so 4 needs to go to 24. Looks just like this. Okay, did that one. 5 goes to 35. Got it. 8 goes to 24. Okay. 2 goes to 20. They already did that one. And 9 goes to 27. All right, is this arrow diagram a function? Look closely at your inputs. Does each input have exactly one output? The answer to that question is yes, right? None of these numbers are the same. So as long as they're going to a number, it doesn't really matter. They will have exactly one output. Now look, I know a lot of you think no because 4 and 8 both go to that same number, 24, but that doesn't matter. Do 4 and 8 have exactly one output? It just happens to be the number 24. It's okay that it's the same number. All right, gang, here we go. Example 2. I got a little happiness for you coming up on example 2. Just wait.
Frank records the ages and heights of the 6 students he tutors in a
Okay.
table. Is the relation a function?
Okay. So again, we saw arrow diagrams in example 1. Now we're going to see a table. Remember, a table, just a collection of ordered pairs. So guys, this is the ordered pair 9, 54, 10, 54, 9, 61, and so on. Okay? So again, if we're asking, is this a function, we need to dedicate our focus into the x values, into the inputs. Do any inputs repeat? Yeah. I've got 2 9s, right? I've got repeating inputs here.
You can't do that.
You can't. I also have repeating 8s in here. If you would like to be a function, you can't do this.
You can't do that.
No, you can't, okay? And they'll go on to tell you about this. There it is. 2 inputs have more than one output. Again, remember what we said. Each input has exactly one output. Well, if we're talking about the input of 9, how many outputs does it have? 2, right? It's got 54 and it has 61. It doesn't have exactly 1. It has exactly 2 in this case, and you don't get to be a function. All right. What happens if our friend Frank reverses the order? He put it in the tumble machine.
Oh, the tumble machine.
You guys remember the tumble machine, right?
It's back.
It's back, baby. It never left. We say it all the time. So if we change that, so now, my friends, if the height is the x value and the age is the y value, is this a function now? So I want you to focus in here just on the x's, right? Do any of these x's repeat?
Yeah.
That's right. I got 2 54s. Look, I get 2 different outputs. So once again, this input 54 has 2 different outputs. Does each input have exactly one output?
No.
No. Is this a function?
No.
No. Absolutely not. Absolutely not. Okay. We're just bebopping right along. Example 3, folks. Folks. You don't know,
Heather
Mr.
and
Mill
her
loves
parents
to
are
say
going
the
to
word
an art
folks.
museum for the day. The parking garage near the museum charges the rates shown in the sign.
Okay. So we're going to the museum all day. This is a scenario we've probably found ourselves in. So we're at like a parking garage and they charge different amounts based on how long you stay, right? Is the cost to park a function, right? So in other words, if all of these time values are your x's, so 1, 2, 3, 4, 5, and all of these are your outputs or your y values, 5, 10, 15, 20, 25, is that a function? Well,
Do we got to use the tumble machine here?
no tumble machine here. So yeah, guys, each hour that we're there has its own unique cost. So clearly this one is a function.
Clearly.
If we were going to stay for more than 6 hours, so if the sign continued on down here and said up to 6 hours, would we pay more than $25?
Yeah.
Mm-hmm. Absolutely. Again, as time increases, what's happening to these numbers? Well, they're increasing too. Okay. So yes, we would pay more than that. And then you get a good thinking question here, guys. Heather claims she can tell exactly how long a family was at the museum by how much they paid for parking. Is she right? Well, so in other words, guys, if I tell you that I paid $15 for parking, can you tell me exactly how long I was in the museum for?
Did you pay exactly $15?
I paid exactly $15.
Well, I think I could tell you.
Mr. Knoll thinks he could, huh? I don't think he could. Why couldn't he? Why couldn't he, guys? If I paid $15, that means, look, up to 3 hours, $15. Mm-hmm.
What do you mean I couldn't? I could.
Mm-mm. It says, can you tell exactly how long I was in the museum?
That's garbage.
Yeah, so guys,
Yeah, you were in there up to 3 hours.
Yeah,
That's
yeah.
what I would say.
look, I could have been in there for 2 hours and 7 minutes. I could have been in there for 2 hours and 48 minutes.
That's garbage.
How much am I paying? I'm still paying $15. But he wanted to know the word exactly, Mr. Knoll. Mr. Knoll's not a good
Exactly.
reader.
You've been exactly up there for.
That's for a while. So anyway, so guys, there's 3-1 for us. So we're gonna go ahead and get into our key concepts now. So that'll be in another video. Maybe I'll be back. Maybe I won't be. Who's to say? Either way, it'll be on page 162. Hope to see you there.